In this concept, we're going to talk about inverse functions and relations. An inverse relation is the set of ordered pairs obtained by reversing the coordinates of each original ordered pair. Okay, so we start with one set, x, y, or some value x, some value y. We end up with y in place of x and x in place of y. Okay, that would be the inverse. Old y, old x, as new x and new y. Okay. Or, well, I could just use a and b, again, in order not to confuse you in terms of the coordinates, we would have b and a. Okay. Here are some examples. So the domain would become the range, and the range will become the domain, obviously, because we're switching x's and y's. So looking at this set of ordered pairs, we have 1 and 2, point 1 and 2, or coordinates 1 and 2, and then coordinates 3 and 4, then coordinates 5 and 6. The inverse relation of x in this case is another relation, y, which has the flipped ordered pairs, as we discussed, right? So it's 2 and 1, 4 and 3, 6 and 5, etc. So in this case, we say x and y are inverse relations. Now, things to keep in mind for inverses, the inverse of a function f of x can be written as f of negative 1 of x, f to the power negative 1 of x. This is not really a power, though. It's not an exponent. Okay, it looks like an exponent, and many of you may actually read it like that, but the proper way to read it is f inverse or inverse of f. Okay, negative 1 is not an exponent or a power in this case. To find the inverse of a function, switch the domain and range as shown in the example below. Let's look at this example. Find the inverse of f of x equals 4x minus 13. So make y equals f of x, right? Just to simplify the manipulation. Easier to manipulate with y than with f of x, So so the equation now becomes y equals 4x minus 13. Now switch x and y. This is essentially the inverse. So in place of y, put an x. In place of x, put a y. Okay? So x equals 4y minus 13. But now solve for y so you can get the new function, the inverse function. Which is this, but I mean get it in terms of y. Okay? Right? In terms of the new y now, which is the inverse of the old function. Okay? So here, y is f of x, but here, y is equal to the inverse of f of x. Okay? Solve for y. So, very simple, right? X, so add 13 to both sides. X plus 13 equals 4y, divide by 4. X plus 13 over 4 equals y. Right? Replace y in this case with the inverse, with f of inverse of f of x, right? Or f inverse of f of x, as I mentioned. So we get f inverse of x is x plus 13 over 4. Okay, so the inverse of f of x equals 4x minus 13 is f inverse of x equals x plus 13 over 4. Okay, so these two functions are inverses of one another. Verifying inverses. So f of x and g of x are inverses if and only if the composite f of g of x and the composite g of f of x, so both the composites of the functions in both orders, right? The first composite, the second, right? And then the second composite, the first. If both composites equal x, okay? X in this case is also known as the identity function. Okay? You can call it I of x equals x. Okay? So the composites in both orders have to equal x, the identity function. Let's look at some examples. Determine whether each pair of functions is an inverse function. Explain your reasoning. F of x equals 4x minus 5. G of x equals x plus 5 over 4. So again, we can use the rule that we just discussed about composites, right? And we can take both composites in both orders. So we can take f of g of x and we can take g of f of x, right? So f of g of x is plugging g in all x's within f, right? Which gives us 4 times, and then in place of this x, we just put in the whole expression for g of x. X plus 5 over 4 minus 5. 4's cancel out. And then you get x plus 5 minus 5, which is 5 minus 5 cancel out, which is just x. Okay? G of f of x is g, and then plug in the expression for f of x into all x's in g. Okay? Which gives us, in this case we have, so x plus 5 over 4. So we need, we can just say, you know, g is also equal to 1/4 x plus 5, you know, just to make it simpler. So 1/4 of x plus 5, and then plugging in, plugging in 4x minus 5 in place of x, right? And then plus 5/4, right? Because this 1/4 is distributed, right? So this is essentially the same as saying 1/4 x plus 5/4, right? Which is exactly what we have here. So then plugging in g for this x, right? We have 1/4 times 4x minus 5 plus 5 over 4. 4's cancel out, so you get x minus 5 over 4 plus 5 over 4. So minus 5 over 4 plus 5 over 4 cancel out, and you end up with x. Okay. So the functions are inverses of each other because f of g of x equals g of f of x equals x. All right. Next example. F of x equals 3x squared and g of x equals square root of x. So again, find f of g and g of f and confirm whether or not they are equal to x, both equal to x. F of g of x equals f with g of x substituted in the x's for f. So take this, plug in for every x in f, and that's f of g. So it's f of square root of x. So 3 times square root of x squared, so square root of x squared is x, and that times 3 is 3x. So we don't even need to find g of f now, right? Why is that? Well, because f of g ended up giving us 3x, not x. So we don't even need to find g of f, right? We could just say directly that because f of g is not equal to x, then f of x and g of x are not inverses of each other. Okay? Okay, very good. So we have some exercises here. Please pause the video, work on these, and come back for the solutions. Okay, let's look at the first exercise. So a set of ordered pairs, right, is provided, and we need to find the inverse of the following, of this set. So, very simple, finding the inverse entails flipping the order of all these numbers, okay, all of these, and then just rewriting the relationship as is. If I can just make my arrows look better, it's a little tricky. There we go. All right. So 3 and 0 becomes 0 and 3. 5 and 3 becomes 3 and 5. 7 and minus 8 becomes minus 8 and 7. Minus 9 and 12. This is 7, close parenthesis. Minus 9 and 12 becomes 12 and minus 9. And 11 and 17 becomes 17 and 11. Okay, so this is my solution. This is the inverse of this. Okay. Next exercise. Find the inverse of f of x equals x minus 1 squared minus 3. So again, rewrite it as y equals x minus 1 squared minus 3. And then flip x's and y's. So x equals y minus 1 squared minus 3. And then just solve for y. X plus 3 equals y minus 1 squared, taking the square root of both sides. So the square root of x plus 3 equals y minus 1. So y equals the square root of x plus 3 plus 1. Okay, the 1 is outside the square root. And this is the inverse of f of x. Okay? Next exercise. Determine whether each pair of functions are inverse functions. Explain your reasoning. F of x equals 1/2 x minus 7/2. G of x equals 2x plus 7. Now again, we talked about the rule of composite functions and how it relates to determining whether functions are or are not inverses of each other. So in this case, we take f of g, we take g of f, and we need both of them to equal x. Okay, this is what we're going to test. Okay, I promise you this is an f. All right. So let's do that. So f of g of x is equal to 1/2, and then plug in all of g into the x's in f of x. So 1/2 times 2x plus 7 minus 7/2, right? Which is equal to 2 cancels with 2, and then 7/2, so you get x plus 7/2 minus 7/2, which is just x, right? And then g of f of x equals, now take f of x and plug it in for all x's in g of x, right? So that gives us 2 times 1/2 x minus 7/2 plus 7 equals 2 cancels with 2 and 2 cancels with 2. So we get x minus 7 from the parentheses and then plus 7, which is equal to x. So both of these functions are inverses. Okay? Last exercise. F of x equals x cubed plus 3. G of x equals the cubic root of x minus 3. So again, we just follow the same process. So find f of g of x, which means plugging in g into all x's in f of x, which is going to give us So g is the square root of x minus 3, cubic root, sorry, not square root. Cubed, right, because it's plugged into x, that is raised to the third power, plus 3 equals. So the cubic root cancels away with the cubic power, and we just get x minus 3 from the parentheses, plus 3, negative 3 and plus 3 cancel out, and we just get x. And we do the same thing for g of f, which means we take the entire expression for f of x and we plug into the x's in g of x. So g of x is the cubic root of x minus 3, but then for that x we take the x cubed plus 3, which is f of x, then minus 3. Okay, so that gives us, so plus 3 minus 3 inside the parentheses, or under the cubic root, essentially cancel out, right? Plus 3 minus 3, so this is 0. So x cubed plus 0, which is just x cubed. So we have the cubic root of x cubed, which is just x, right? So in this case also, both functions are inverses. Okay? And this is it for this concept. See you in the next video.